Hey everybody, and welcome to our fifth video on the S-block elements and their compounds. This is the first video of the fifth lecture, and this time we'll be looking at the oxoanions, or a couple of them, of S-block elements. So to start, let's look at what an oxoanion actually is. Now these are ions, and they have a general formula of AXOYZ-. And you can get lots of oxoanions. They can be formed by most of the elements, so I've got some examples of commonly found ones here. So we've got a PO4 3- is phosphate, CrO4 2- is chromate, MnO4- is permanganate, and SO4 2- is sulfate. And these are used quite a lot. Now all of these oxoanions have related oxyacids if they're associated with hydrogen. These oxyacids have the general formula of HZAXO3, and the number of hydrogens you can see is Z. That corresponds or balances out how many negative charges there are. So for example, PO4 3- has a related oxyacid that's H3PO4, and this is phosphoric acid. And likewise with the sulfate on the end, this is another common oxyacid. You can get H2SO4, and this is sulfuric acid. Very common one in the lab. Now it's important to know that quite a lot of elements can actually have multiple oxoanions, so it's not just sulfate or phosphate. And we'll be looking at an example on the next slide. And it's important, you don't need to know the background of oxoanions for the exam. It's just more so you have an idea of how they fit into chemistry in general, what they are. Because in the group 1 and 2 compounds, we're only going to be focusing on carbonates and nitrates. So CO3 2- and NO3-. We'll also see about nitrites on the next slide as well. So the group 1 oxoanions, we'll start by looking at the group 1 nitrates. Now most of these decompose on heating to form nitrites. Now this is an example of what I was saying on the last page of elements having multiple oxoanions. So we've got the nitrate anion is NO3-, and also the nitrite oxoanion, which is NO2-. So as I was saying, most of the group 1 nitrates will decompose on heating to form the nitrites, as shown in this equation, and one equivalent of molecular oxygen in the gas phase. Lithium is slightly different. We've seen before that lithium decomposes a bit differently with hydroxides. So all the other hydroxides were stable, but lithium hydroxide did decompose upon heating. This time, lithium nitrate does still decompose upon heating, but instead of going to the nitrite like the rest of the group 1 metals, this time it decomposes to the oxide, lithium oxide, and releases 4 equivalents of NO and 3 equivalents of molecular oxygen. Now I haven't written it here, but I've got the equation here anyway. But the carbonate does the same. So all the other group 1 carbonates are stable. So this is, as I was saying, much more similar to the hydroxides. Most of the group 1 carbonates are very stable. Upon heating they won't decompose, but lithium carbonate is an exception. So we've got lithium carbonate, Li2CO3, and this will decompose into Li2O and CO2 in the gas phase. Now these compounds become more stable down the group, and this is for the same reason that we saw the peroxides in the one of the earlier videos getting more stable down the group. It's from the whole cation size ratio. So we said that larger cations are stabilized by larger anions. Now these oxoanions are pretty large anions. So you'll see that they're less stable at the top because lithium's a very small cation, and the stability increases down the group as the cation size increases. And then finally, let's compare these to the group 2 oxoanions. So we'll start again by looking at the nitrates. And this time you'll see that they very much follow how the lithium nitrate decomposes upon heating. So these don't form the nitrites. All the group 2 nitrates follow the same decomposition equation, which is shown here. Oh, let's get the laser up. Yes, here. So upon heating, the group 2 nitrates will decompose into the group 2 oxides and release 4 equivalents of NO and 3 equivalents of molecular oxygen. So as I say, that's very much following how lithium nitrate decomposed. And looking at the carbonates this time, I've said they're mostly insoluble. We'll be delving more into the solubility of group 1 and 2 compounds in the next video. But this time it's again quite similar to what happens with lithium. So the group 2 carbonates do decompose upon heating, and it's again to the oxides and CO2. So we've got the general equation here. The metal carbonate goes to the metal oxide and 1 equivalent of CO2 in the gas phase. And again, much like the group 1 oxoanions, the stability of carbonates and nitrates increases down the group. And this is again because they're very large anions. They're stabilized by large cations. So as we go down the group, the cation size increases and therefore stability of the compound increases also.